This video continues with transactions. When two or more users have access to the database, it is possible for them to be working with the same data at the same time. This is called concurrency. Concurrency is not a problem when users are just retrieving the data at the same time. However, it is a problem when you try to update the data. SQL Server can lock data resources at different levels. The levels form a hierarchy based on granularity, which refers to the amount of data the resource encompasses. A resource that encompasses more data than another resource is said to be less granular or coarser than the other resource. A coarse-grained lock affects more data than a fine-grained lock. Locking is automatically enabled and controlled by a SQL Server application called the Lock Manager. Maintaining several fine-grained locks requires greater server resources than maintaining one coarse-grained lock. For this reason, the Lock Manager will automatically convert multiple fine-grained locks on the same resource into a single coarse-grained lock. This is known as lock escalation. SQL Server automatically determines the appropriate lock mode for your transaction. In general, retrieval operations acquire shared locks, and update operations acquire exclusive locks. If a resource is already locked by a transaction, a request by another transaction to acquire a lock on the same resource will be granted or denied depending on the compatibility of the two lock modes. For example, if a transaction has a shared lock on a table and another transaction requests an exclusive lock on the same table, the lock is not granted. The second transaction must wait until the first transaction releases its lock. You can read more about this in the textbook. A deadlock occurs when two transactions are simultaneously holding and requesting a lock on each other's resource. Since deadlocks can occur more frequently at higher isolation levels, you need to understand how they come about and how you can prevent them. How the deadlock occurs. Transaction A requests and acquires a shared lock on the invoice line items table. Transaction B requests and acquires a shared lock on the invoices table. Transaction A tries to acquire an exclusive lock on the invoices table to perform the update. Since transaction B already holds a shared lock on this table, transaction A must wait for the exclusive lock. Transaction B tries to acquire an exclusive lock on the invoice line items table, but must wait because transaction A holds a shared lock on that table. Here are some coding techniques to avoid deadlocks. Don't allow transactions to remain open for very long. Keep transactions short. Keep select statements outside of the transaction except when absolutely necessary. Never code requests for user input during an open transaction. Use the lowest possible transaction isolation level. The default level of read committed is almost always sufficient. Reserve the use of higher levels for short transactions that make changes to data where integrity is vital. And continuing this, make large changes when you can be assured of nearly exclusive access. If you need to change millions of rows in an active table, don't do so during hours of peak usage. If possible, give yourself exclusive access to the database before making large changes. Consider locking when coding your transactions. If you need to code two or more transactions that update the same resources, code the updates in the same order in each transaction. And we will cover performance in a separate video.